This is an example of a hypothesis test for a population mean when sigma is known using the p-value method. And this example is a left-tailed or lower-tailed test. A simple random sample of 50 adults is obtained, and each person's red blood cell count in cells per microliter is measured. The sample mean is 5.23. The population standard deviation for red blood cell count is 0.54. Use a level of significance of 0.01 to test the claim that the sample is from a population with a mean less than 5.4, which is a value often used for the upper limit of the range of normal values. Alright, so this is a z-test, and the reason why this is a z-test is because the population standard deviation is known and our sample size is greater than 30. We need to write the null and the alternative in terms of the population parameter mu, first by identifying the claim. The claim is that the sample is from a population with a mean less than 5.4. So that's going to be mu less than 5.4. This is the claim. Because the claim does not contain the case of equality, the claim is the alternative. And the null is mu is equal to 5.4. The null statement always contains the case of equality. Now I want to use the p-value method for this. And we're going to need our standardized test statistic, which follows the z-distribution. It's what we observe minus what is hypothesized over sigma over the square root of n. So from the problem, x bar was 5.23. Our assumed population standard deviation is 0.54, and our sample size is 50. So if you want to find this standardized test statistic by hand, your numerator expression will be 5.23 minus 5.4 over 0.54 over the square root of 50. And I suggest using parentheses when using your calculator. I'm going to go ahead and go to the TI-84's z-test option to get this directly. Going to the stat menu, over to tests. First option is the z-test, and I have the summary statistics rather than the data in a list. I'm changing my null statement to match the value in the hypotheses. My assumed population standard deviation, let me clear that. My assumed population standard deviation was 0.54, and my sample mean was 5.23. I need to change the sample size as well as the direction of the alternative to less than, and calculate. The standardized test statistic rounded to 3 decimal places is negative 2.226. And the screen also outputs the corresponding p-value. So for this problem, the p-value is 0.013. And if your p-value is less than your level of significance, you will fail to reject the null. Now what the p-value represents is it's an area or a probability that's associated with the standardized test statistic. Because this is a lower tail test, the area I want to shade that goes along with the test statistic is going to be further to the left of negative 2.226. Okay, so this area will be the p-value. When your p-value compared to your level of significance, and in this problem it's 0.01, when your p-value is greater than or equal to your level of significance, the decision is to fail to reject. Now these two values are very close together. This is only a smidge above our level of significance. So for example, if I changed my level of significance to 0.05, the decision would then be to reject the null. So it is possible to fail to reject at one level of significance using the p-value method and reject at another. But we do want to base our conclusion on the nominal or the stated level of significance. So we are going to be using this criteria right here. So the claim is the alternative, and we're failing to reject the null. So the correct way to say this is that there is insufficient evidence, or there is not enough evidence to support the claim that the sample is from a population with a mean less than 5.4.